Hello students, welcome to ePhysics. Students, since your board exams are near, I will be providing you a question series videos. Okay? Now, in the question series videos, I will be providing you with the answer writing process of the questions which have already been asked in the previous years in the board exams. So here in this video we will be starting with the electric charges and fields. This is the first part of the video, and here we will be discussing about two important topics questions, that is one from the dipole and the second that is from the Coulomb's law. Okay, so let's start it. The first question is on the screen, students. It says the 2 point charges having equal charges are separated by 1 meter experiences a force of 8 Newton. Okay. Now, when we talk about 2 point charges, let us consider we have two charges Q1 and Q2. Both are of equal magnitude. Okay. Equal charges, it is already given over here, and they are separated by a distance of 1 meter. Okay, and the force acting between them is 8 Newton. 8 Newton, when it is saying, then the force acting between them, then it is equals to 8 Newton. Why I have written air over here? I could have also written vacuum because no medium has been given so far in the first sentence of the question. पहले सेंटेंस में मीडियम नहीं दिया गया है, इसीलिए हमने इसे एयर कंसिडर किया है. हम लोग इसे वैक्यूम भी कंसिडर कर सकते थे. ओके, नाउ व्हाट विल बी द एक्सपीरियंस, what will be the force experienced by them if they are held in water at the same distance? Now, if we put this whole system, okay, if we put this whole system in water, then what will be the force experienced between these two charges? We have to find that. And the dielectric constant of water has been given, that is equals to 80. Okay, now let's start it. Students, we have been knowing the Coulomb's law that force is equals to 1 by 4 pi epsilon naught q1 q2 upon square of distance between them. And this is for any medium. Let us consider this is for air. And for any medium, students, we have been knowing, for any medium we have been knowing it is equals to 1 by 4 pi epsilon naught multiplied by dielectric constant, okay, into q1 q2 upon r square. Now we have to find the force in the medium, that is here the medium is water. How can we find it? Students, we have been given the distance between them. Okay, distance between them is 1 meter, whether it is kept in air or it is kept in water, the distance between them is 1 meter in both the cases, and both the charges are of equal magnitude. And how can we find it? We have one way that we can find the value of the force when the system is kept into water. And if we find the ratio of it, that is force acting between the charges in air divided by force acting between the charges in water, okay, when we find it, we get for air it is equals to 1 by 4 pi epsilon naught q1 q2 upon r square divided by force in water, force in medium, that is equals to 1 by 4 pi epsilon naught q1 q2 upon r square. So we can simply write it over here, 4 pi k, that is dielectric constant, epsilon naught r square divided by q1 multiplied by q2. Now from here, students, we can clearly see q1 q2 q1 q2 gets cancelled, 4 pi epsilon naught and 4 pi epsilon naught get cancelled, r square and r square gets cancelled. So we are left with force upon force in air divided by force in water is equals to k. Here this dielectric constant is only left over. So force in air is already been given, that is 8 Newton divided by force in water is equals to k. K ka value in water has been given, that is equals to 80. So finally we get to the conclusion that force in water will be equal to 8 upon 80 Newton, which is equals to 1 upon 10 Newton. So you can also put it in decimal, that is 0.1 Newton. So this is how you will have to write the answer in the board exam. This is the one of the simplest questions that we could have seen. So let's move to the next question now. Now the second question is on the screen, students. A dipole moment P vector is present in an uniform electric field E. So this is the first sentence. Dipole moment P has been kept in any uniform electric field and the value is capital E vector. Now we have to find the value of angle between the dipole moment P and electric field E for which the torque experienced by the dipole is minimum. Okay, now let us consider that torque, that we have been knowing the formula torque is equals to dipole multiplied by the electric field. Okay, now for the magnitude we could be writing it as magnitude of torque is equals to P, since it is a cross product, so we can write it as P E sine theta. Why we have taken the magnitude? Because we were supposed to be finding the angle. Now when we are talking about angle, we need theta in the formula. In the initial formula here we were not having theta, that is why we have solved it furthermore and we have simplified it as P cross E is equals to P E sine theta. It is given in the question that the torque experienced by the dipole should be minimum. So the minimum value of torque will be equal to 0. Okay, the minimum value will be equal to 0 and this is according to the question. According to the question. Okay, now torque we have been knowing, it is equals to P E sine theta equals to 0 degree. Okay, now it can further be written as sine theta is equals to 0 degree, because 0 divided by P into E will be 0 of course. Now for sine theta equal to 0, the value of theta can be, the value of theta can be 0 degree and 180 degree. Okay, because we have been knowing that sine 0 degree is equals to 0, also sine 180 degree is also equals to 0. Therefore for the minimum torque experienced by the dipole kept in a uniform electric field, the angle between P and E should be either 0 or 180 degree. Okay, so this is how you will be writing the answer in the board exam. So let's move to the the third question now. Now the next question is on the screen, students. An electric dipole of length 4 centimeter. Okay, the dipole length has been given, that is equals to 4 centimeters. So we should write it, the dipole length, that is 2a, is equals to 4 centimeter. Okay, so if we convert it into meter, it becomes 4 multiplied by 10 to the power minus 2 meters. Okay, why we have taken 2a? Because when we talk about dipole, we have been using the formula 2a. Okay, in formula we have been writing it as 2a. From the point we were considering a distance on both the sides from the point where we were supposed to be calculating the dipole. So we are considering it as 2a is equals to 4 centimeter as given in the question, which is making the angle that is theta is equals to 60 degree. Okay, with the uniform electric field, the uniform electric field, that is E. Okay, now the experiences a torque. It experiences a torque. Torque has been given over here, that is equals to 4 root under 3 Newton meter. Okay, now we have to find the potential energy. Potential energy is supposed to be found, which is denoted by U, and we have to find it. Okay, now let's solve it. We are supposed to be finding the potential energy. Now students, we know the formula of potential energy. U is equals to minus dipole moment multiplied by the electric field into cos theta. We know from here we can find P. We have theta, so we can find the value of cos theta as well, but we don't have the value of E over here. Okay, and the value of charge has also been given, that is plus minus 8 nano coulomb. Okay, nano means, so let me write it over here first. The value of charge Q is equals to plus minus 8 into 10 to the power, nano means 10 to the power minus 9 coulomb. Okay, charge is also been given, therefore we can find the value of P. Now for potential energy we need to have three things over here, that is theta, so that we can find the value of cos theta. P, dipole moment, so we can find it from here, the given things, but we don't have the value of E, that we have to find now. Now students, we have been knowing a formula, that is torque is equals to P E sin theta. Okay, torque is equals to Pe sin theta. Now torque is equals to, now when we talk about P, that is dipole moment is equals to 2a into q. Okay, this is the formula of dipole moment, into E sin theta. Okay, so from here E is equals to, E will be equal to torque divided by 2a into q into sine theta. So this is how we will be solving it. Now let's move now. So we can again write it as E is equals to torque. The value of torque is given, that is 4 root under 3. Okay, divided by 2 into a, we have taken the length of the dipole is equals to 4, and we can write it as 4 into 10 to the power minus 2 meters, and the value of charge is also been given, that is 8 into 10 to the power minus of 9 nano coulomb into sin 30, and theta ka value, sorry, sin theta ka value is 60 degree, so we can write it as sin 60 degree. Okay, now let's solve it. So after solving it, we will get the formula. This will be equals to Newton per coulomb. So after solving it, you will get it is equals to 2.5 into 10 to the power 10 Newton per coulomb. Okay, now for potential energy, we needed P E cos theta. So we have found the value of E now over here. So we can put it in the formula of potential energy. Therefore, potential energy U is equals to minus P E cos theta. Okay, which is equals to minus 2a into q into e into cos theta, which is equals to minus 2a का value is 4 into 10 to the power minus 2 into q का value is 8 into 10 to the power minus 9 into e का value is 2.5 into 10 to the power 10 into cos theta का value is, of course, we have taken it as 60 degree, theta 60 degree. Now when we solve it, we will get the answer that is equals to minus 4 joule. So this is how we solve these kind of questions in the board exam. You will be writing it. The annotated PDF will be provided in the description link Telegram channel. Okay, so you don't have to take the screenshot all the time, or you just see, you just watch the video, just understand how the things have been solved over here. So let's move to the second question. Now the next question is on the screen, students. 2 point charges q plus q and minus of 2q, that is plus of q and minus of 2q, are kept at a distance d. The distance between these two charges are d. Find the location of the point relative to charge to q at which the potential due to this system is 0. We have to find the potential due to this system is 0. Let us consider that point is somewhere around here. Let us consider this point is P, and the distance between plus charge Q and P, let us consider this is x units, and the distance between Q and minus of 2Q is d minus x, units. Okay, now how will we solve it? Now it is given in the question that the potential is equals to 0. So therefore 1 by 4 pi epsilon naught q upon x, the formula of potential for plus q charge, plus 1 by 4 pi epsilon naught charge is equals to minus of 2q, divided by the distance between them, that is d minus x. It should be equal to 0. Now when we solve it further, we get 1 by 4 pi epsilon naught q upon x, and this, when this part is shifted on the right hand side, this is negative, will become positive of 2q divided by 4 pi epsilon naught d minus x. Okay, now let's solve it. 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught gets cancelled, q and q also gets cancelled. Now when we solve it, we get d minus x is equals to 2 into x. Okay, now further when we solve it, d is equals to 2x. When this negative of x will shift to the right hand side, it will become plus of x, which can further be written as d is equals to 3x. So we were supposed to be finding the value of x, that is the distance between q and p, which is equals to d upon 3. So the required point is at a distance d upon 3 from charge q, where the potential energy is equals to 0. So this is how you will be writing these kind of answers into your board exams. Now let's move to the next question now. Now the next question is on the screen, students. And dipole moment is placed in an uniform electric field E with the dipole moment P parallel to the field. Parallel to the field means theta is equals to 0 degree. Okay, now the work done, the first part of the question says the work done in turning the dipole till its dipole moment point in the direction opposite to E. Opposite means if it initially it was in this direction, let us consider theta 1, we have considered it as theta is equals to 0 degree. Now when it is in the opposite direction, therefore in this case the theta will be equal to 180 degree. So we were supposed to be finding the work done from theta 1 to theta 2. and in the value of theta 1 is equals to 0 and the value of theta 2 is equals to 180 degree. So let's solve the first part of the question first. Okay, now the work done for the first part, the work done is equals to, we have been knowing the formula, integration from theta 1 to theta 2 is multiplied by tau d theta. Okay, now this is equals to theta 1 we have considered it as 0 degree and theta 2 will be equal to 180 degree. We can also write it as pi only. Okay, now tau ka value is equals to pe sine theta d theta. Why we are taking sine theta, pe sine theta in place of tau? Because we were supposed to be integrating with respect to theta. Now when we integrate it, p and e are kept constant, that is from 0 to pi integration of sine theta d theta, which can be written as pe. The integration of sine theta is minus of cos theta 0 to pi. Okay, which can further be written as work done is equals to pe upper limit minus lower limit. Upper limit is minus of cos pi minus minus plus cos 0 degree. Okay, which can be further written as pe. Okay, pe 1 plus 1. Okay, so this can further be written as twice of pe. So the work done from rotating the dipole from 0 degree to 180 degree is equals to twice of p into e. Now let's see the second part of the question. The orientation of the dipole for which the torque acting on it becomes maximum. For it becoming maximum, we have to find that for sine theta, the value of sine theta, for being it maximum, it should be equal to pi by 2, that is equals to 90 degree. So let's solve the second part now. Okay, so tau is equals to pe sine theta for becoming maximum value, for maximum value theta should be equal to pi by 2. So we can write it as tau is equals to pe sine pi by 2. Pi by 2, that is 90 degree. Sine 90 is equals to 1. Therefore tau is equals to pe. So this is the maximum torque. Okay, this is the maximum torque. So this is how you will be writing the question in the board exam of such kind of questions, for such kind of questions. Okay, now let's move to the next part, next question. Now the next question is on the screen, students. A dipole is present in an electrostatic field of magnitude. Electrostatic field's magnitude is given, that is E is equals to 10 to the power 6 Newton per Coulomb. Okay, if the work done in rotating it from its position of stable equilibrium. Stable equilibrium, let us consider theta 1. Stable means theta should be equal to 0 degree and it is moved to the position of unstable equilibrium. For unstable equilibrium, theta should be equal to 180 degree. The previous question we have solved and that was similar to this one only. And it is, the work done is been given, that is equals to 2 into 10 to the power minus 23 joule. So work done is equals to 2 into 10 to the power minus 23 joule. So we have to find the magnitude of the dipole moment, that is P. Now students, we have been knowing that work done in case of dipole moment is equals to PE cos theta, okay, cos theta 2 minus cos theta 1. In the previous question we have solved or derived this formula as well over there and we got it as twice of PE. Okay, how do we get PE? This is discussed in the previous question. You can just move backwards in the video and watch it again. So here work done is equals to twice of PE. Therefore the dipole is equals to work done upon twice of E. The value of work done has been given, that is 2 into 10 to the power minus 23 divided by 2 into E. E ka value has also been given, that is 10 to the power 6 Newton per coulomb meter, which is equals to 10 to the power minus 29. This 2 and 2 gets cancelled. Coulomb meter. So this is how you will be solving such kind of questions. So let's move to the next question now. So now the next question is again on the screen, students. Deduce the expression for the electric field E due to the system of two charges Q1 and Q2 with the position vector R1 and R2 at a point R with respect to the common origin. Okay, at any point R. So from the question we can draw the graph as, let's draw the diagram first. Let us consider we have 2 point charges Q1 and Q2. Q1 is at a distance R1 and Q2 is at a distance R2. So we have to find the electric field at point which is at a distance R from the origin. Okay, this is R, this is R1, this is R2, and this is R. Okay, now let's solve it. Now the position vector will be somewhere like it. That let us consider this is the second charge, so this will be electric field due to the second charge. This will be the electric field direction due to the first charge. Okay, now electric field intensity at point P, let us consider this is point P. So electric field intensity at point P, okay, due to charge Q1, due to this charge Q1 is equals to, let us consider this is E1 is equals to 1 by 4 pi epsilon naught. Since we are talking about the vector quantity, so we will be writing it as R, this is equals to this part is equals to R minus R vector minus R1 vector. Okay, and here we will have to multiply it to the unit vector, that is the direction of Q1P. Okay, this is equals to R minus R1. Okay, now electric field intensity at point P due to charge Q2, it will be written as E2 is equals to 1 by 4 pi epsilon naught Q2 upon R1. This distance is equals to R1, sorry, R vector minus R2 vector multiplied by the unit vector, that is R1 R minus R2. Okay, so sorry, I forgot to write the cube over here, cube in the power. Okay, now the net electric field, therefore the net electric field intensity at point P will be equal to the sum of both, that is E is equals to E1 plus E2, which can be written as 1 by 4 pi epsilon naught. If we take this part common in both, 1 by 4 pi epsilon naught and 1 by 4 pi epsilon naught in both the cases, so we are left with Q1 divided by R vector minus R1 vector cube multiplied by the unit vector R minus R1 vector, okay, plus Q2 divided by R vector minus R2 vector का whole cube multiplied by R vector minus R2 vector. So this is how we solve these kind of questions. Hope you get it. Now let's move to the next question now. Now the next question is again on the screen. Students, two charges plus q and minus q are kept at a point minus x2 0 and x1 0 respectively. That is, let me draw the figure first. Let us consider we have plus q charge and minus q charge. Okay, and let us consider we have the origin. This one is the origin 0 0. Okay, this is minus x2 0 and this is x1 0. Okay, this is how we write it according to the question. Okay, now find the magnitude. We have to find the magnitude and the direction of the net electric field. Magnitude and the net electric field. Since this is x1 0, this distance will be equal to x1, and since this is x2 0, this distance will be equal to x2. Okay, now let us consider this is point A, this is point B, and this is the origin O. Now the electric field intensity at O, electric field intensity at point O due to the positive charge Q, let us consider E1 is equals to 1 by 4 pi epsilon naught Q upon, since it is a positive charge, so it is Q upon x2 ka whole square. Okay, and this will be towards B. Both the charges are along the direction of O to P. Okay, so we can write it as towards B. Let us consider this is equation 1. An electric field intensity at point O due to negative charge Q. We can write it as E2 is equals to 1 by 4 pi epsilon naught. Okay, 1 by 4 pi epsilon naught, again because of the magnitude are same, so it is Q upon the square of distance between them, that is x1 ka whole square. It is also towards B. Okay, this is second question equation. Now the net electric field, why we are taking towards B? Because E1 and E2 act along the same direction, okay. Now therefore the net electric field intensity at point O, that is E, will be equal to E1 plus of E2, and we have been knowing the value of E1 is equals to 1 by 4 pi epsilon naught Q upon x2 ka whole square plus 1 by 4 pi epsilon naught Q upon x1 ka whole square. Okay, this is E. So we can finally write it as Q is common in both, 1 by 4 pi epsilon naught is also common in both, so inside we are left with 1 upon x2 ka whole square plus 1 upon x1 ka whole square. So this is how we solve these kind of questions. So hope you understood it. Now these are the few questions, students, from the first part of the first chapter, that is electric charges and fields, okay, of class 12. So these are the process, or these are the ways how you can write your answers efficiently in the board exam, so that you can get good marks. Okay, we will be coming with the more videos with more questions and more processes. Okay, thank you very much for watching the video.